Hi everyone, in this video I'll be going through chapter 5 revision set B questions. Okay, so I'll go through the questions one by one so you can skip to the questions which you feel that you need help going through. Let's start by question 1. B1. The curve with the equation y equals to a times e power bx passes through these 2 points. Find the value of a and b. Okay, so if the curve passes through these 2 points, this means that the x coordinate and y coordinate will satisfy this equation over here. So what I can do is simply to sub in the coordinates that the curve passes through into this equation. So over here, very simply, I will sub 0.5 comma 1.1 into equation of curve. So for the first part, if I were to sub this point in, I will get 1.1 equals to a times e power b times 0.5. So this is simply 0.5b. Okay, 0.5b. Okay, likewise, I can also do the same thing for the other point. So over here, for the other point as well, when I were to sub in the other point, 1.5 comma 0.15, this satisfies the equation of the curve. I will get 0.15 equals to a e power 1.5b. Okay, so now I have two different equations, equation 1 and equation 2. What can I do to find the value of a and b? Very simply, this is like solving simultaneous equation, but a different kind of simultaneous equation. I can call this equation 1. I can call this equation 2. Okay, so over here, what can I do? Very simply, there is no way by adding or subtracting I can get rid of one variable. When we have simultaneous equation, we must always find a way to get rid of one variable, either a or b, such that we can solve for the other variable. So I hope that you can see that very clearly. The logical step in this case would be to divide one equation by the other. So let's see if I take equation 2 divided by equation 1. Okay, so over here, my next step, I take equation 2 divided by equation 1. Okay, so this means that over here, on the left side, it will be 1.1, sorry, not 1.1, 0.15 divided by 1.1 on the left side of the equation is equal to, now the right side of the equation is a times e power 1.5b divided by a e power 0.5b. Okay, then now by simple cancellation, a common factor I can cancel out. Then if I have same base e, I can simply combine these two indices here by subtracting the power, because this is this thing divided by this thing over here. Since they have the same base, this is simply 1.5b minus away 0.5b. Okay, so over here this is simply 0.15 over 1.1 equals to e 1.5b minus away 0.5b will simply give me 1b, okay, which is simply e power b. Okay, so therefore I have an unknown power here. What can I do to bring down unknown powers? I can take logarithm. In this case here, since my base is e, I can take ln on both sides. If I were to take ln on both sides, this will become ln 0.15 over 1.1. This is ln to the entire fraction here, equals to ln e power b. Okay, therefore, I can bring the unknown power down. Ln e is simply 1. So this means that b is equal to ln 0.15 over 1.1. Okay, therefore press this in your calculator, you will get about negative 1.9924. Round off to 3SF, your answer for b should be negative 1.99. Round off to 3SF. Okay, so once I find the value for b, all I need to do is sub into back to the original equation. Let's say I sub b equals to, I use the 5SF version, 1.9924 into either equation 1 or equation 2. Let's say I choose equation 1. Okay, this means that 1.1 is equal to a e power 0.5 times negative 1.9924. Okay, therefore a is simply equals to 1.1 divided by e power 0.5 times negative 1.9924. Okay, so therefore press this in your calculator correctly. Your final answer for a should be simply 2.98, round off to 3SF. Okay, and this is your solution to question 1 of set B. Alright, let's now move on to question 2. Okay, let's look at question 2 here. Using appropriate substitution, solve the following equation. So whenever you use substitution, I always choose our sub u equals to something power x. So in this case over here, let's look at equation 1. Okay, part A. 5 power x plus 5 equals to 30 times 5 power x minus 1. Okay, in order to use substitution first, I must first break apart my terms to obtain just the 5 power x. So by breaking apart, I will get 5 power x plus 5 equals to 30 times 5 power x times 5 power negative 1. Okay, so over here, by substitution, I can use let u be equals to 5 power x. So therefore, can simplify this equation to become u plus 5 is equal to 30 times u times 5 power negative 1 is simply 1 over 5. Okay, then I simplify the right side. U plus 5 is equal to 30 times u over 5. This whole thing here is just u over 5. So this whole thing times 30, I'll get 6u. Okay, which means that therefore 5u is equal to 5, u is equal to 1. Okay, but remember when you solve such equations, right? Solve means I want to find the value of x. U is just a substitution I'm using to make this solving for x easier. So once I found value of u, I'll replace my u back with 5 power x is equal to 1. And in order for 5 power x to be equals to 1, in this case here, therefore, x must be equals to 0. Okay, and that is my answer for part A. Alright, so now let's look at part B. Okay, maybe let me shift this up so that I can have more space to write. Okay, let's look at part B now. Okay, part B here. Okay, I have 9 power x plus 10 times 3 power x equals to 3x plus 2 plus 12. Okay, one important thing to do whenever I see unknown powers but different base, you must always try to make them the same base, and I try to separate all the base with power x. Okay, so in this case over here, 9 x is simply 3 square. 3 square is simply, this can be written as 3 power 2x plus 10 power 3x equals to, in this case here, I can split apart as well to make it easier to see how to use substitution. 3 power x times 3 square plus 12. Okay, therefore, I'll use the substitution. Let u be equals to 3 power x. So this means that, in this case here, u square plus 10u equals to u times 3 square, which is 9u plus 12. Okay, so over here, this means that if I were to make this a quadratic equation, I'll get u square plus u minus 12 equals to 0. Okay, factorize this, I'll get u minus 3 times u plus 4 equals to 0. This means that u is equal to 3 or u is equal to negative 4. Okay, remember the last step is I'm not solving for u, I'm solving for x. So I will replace back the u with x, in this case here, 3 power x is equal to 3 or 3 power x is equal to negative 4. Over here on the left side here, 3 power x is equal to 3, therefore x is equal to 1. And on the right side here, 3 power x, this number can never be a negative number. It can never be negative 4. So therefore, rejected as 3 power x is strictly positive. Okay, and therefore your final answer to this question is x equals to 1. Okay, this is for question B2. Alright, now let's move on to question B3. Okay, B3 here. Without using a calculator, solve each of the following equation. Let's look at equation 1. Okay, equation 1 here. Log base 9. 3x plus power x plus 1 the whole equals to x squared. What can I do? Okay, so over here, this is my logarithmic form. To solve this, let's turn this to exponential form to make life easier. Okay, remember how do I turn this to exponential form? This means that in order to get this number here, the base 9 must have a power of x squared. Okay, so over here, this means that to get 3 power x plus 1, base 9 must have a power of x squared. Okay, therefore, from here, I see base 3 and 9. I can make them the same base. 9 can be written as 3 squared. 3x plus 1 is equal to 3 squared, the whole thing, power x squared. This can be simplified to 3 power x plus 1 equals to 3. This is 2 times x squared. This will be 2x squared. Okay, once they have the same base, now I can compare the power straight away. Therefore, x plus 1 is equal to 2x squared. Okay, Simplify this into a quadratic equation. 2x squared minus x minus 1 is equal to 0. I can solve this quadratic equation by factorization. I will get x minus 1 times 2x plus 1 equals to 0. This means that therefore x is equal to 1 or x is equal to negative half. Okay, and this is the solution to part A without a calculator. Okay, so let's now look at part B. Okay, part B over here, I'm going to write this here. Part B, okay, I have 4 power 3x plus log base 2, 1 over 8 equals to 5. Solve this without a calculator. So let's do this step by step. Okay, I have 4 power 3x here. Let's solve this log first. Log base 2. I have a 1 over 8 here. Make life easier. I turn 1 over 8 to a power of 2. I hope you can recognize 1 over 8 is simply 2 power negative 3 equals to 5. Okay, therefore I can bring down the unknown powers from log terms. This will be plus, or it can be minus 3 log base 2 equals to 5. So therefore 4 power 3x is log base 2 is 1. So 4 power 3x minus 3 times 1, which is just 3, is equal to 5. Okay, therefore 4 power 3x is equal to 5 plus 3, which is 8. Okay, then now, different base, how to solve? 4 and 8 can be simplified further, make them base 2. So this is simply 2 square power 3x. This is equal to 2 power 3. Therefore, this is 2 power 6x is equal to 2 power 3. Therefore, 6x is equal to 3, x is equal to half. Okay, and this is for part B. Alright, let's now move on to part C. Okay, part C here, let me write the equation down. Part C, log base 2x squared minus log base 2 times 2x plus 5 equals to 2. Okay, part C here. Okay, how do I solve this equation here? Maybe I need another page. Okay, part C here. Okay, part C here. Okay, so in order to solve this equation first, maybe what I can do is to first combine these two log terms on the left side together. Since they have the same base, okay, coefficient here is 1 and 1. 1 and 1. I can use my quotient rule to combine these together. This will become log base 2 x squared divided by 2x plus 5 equals to 2. Okay, and therefore we can further simplify this. Okay, can convert this to exponential form. How to convert to exponential form? In order to get this, my base 2 must have a power of 2. So this means that x squared over 2x plus 5 is equal to 2 squared. Okay, so therefore x squared over 2x plus 5 is equal to 4. Cross multiply, x squared is equal to 8x plus 20. Therefore, x squared minus 8x minus 20 is equal to 0. Okay, so therefore by factorization, I'll get x plus 20 times x minus 10. Sorry, not x plus 20, but x plus 2 times x minus 10 equals to 0. Okay, therefore over here, x is equal to negative 2 or x equals to 10. And that is my answer for part C. Okay, last question. Log base 2x equals to 4 log base x 2. So part D here. Log base 2x is equal to 4 log base x2. Okay, how to solve this? Remember, whenever I want to solve log equation, I'll try to make sure they have the same base first before I can do anything. So let's easier to get rid of unknown bases. Let's change this base x to base 2. So log base 2x is equal to 4. How do I change base? I hope you still remember by the change of base formula. This is log base, the new base 2 over the top number 2 over log base 2 new base over the bottom initial base x. Okay, then simplify from here. This is simply log base 2x equals to 4 will multiply to the numerator. Log base 2 is 1. So this is 4 over log base 2x. Okay, then now get rid of the fraction, cross multiply. This times this will give me log base 2x, the whole thing square, equals to 4. Okay, which means that log base 2x, I square root unknown numbers, I'll get plus minus 2. Okay, so therefore this means that over here, it means that log base 2x is equal to positive 2, or log base 2x is equal to negative 2. Okay, so therefore, that means to get this number here, x is simply equals to base 2 power 2, which is equal to 4. Or to get this x over here on the right side, the base must have a power of negative 2. It's equal to 2 power negative 2, which in this case is 1 over 4. Okay, and that is the answer for part D. Alright, so this is for question number 3. Alright, so now let's move on to question number 4. Okay, question number 4 here, I'm given a population model. At the beginning of 2005, the population is 12,000. Given that the population P after n years is given by this model function here. Find the population at the beginning of 2020. Okay, so over here, let's write out the equation. Maybe this population here, to make it easier, I'll call it P. I call this population P. Okay, so over here, I'm given the equation. Population is equal to 12,000. E power is 0.07n. Okay, so over here, estimate population at the beginning of 2020. So at beginning of 2020, we first determine what is the number of years of 2020. From 2005 to 2020, n will be equal to 15 years. 15 years will have passed. Okay, so therefore, when n is equal to 15, population P is equal to 12,000 times e power 0.07 times 15. Okay, then just press in your calculator. You should get estimate to 3SF 34,300, round off to 3SF. Okay, this is for part 1. Okay, now let's look at part 2. Okay, part 2 here, the year in which a population will be expected to first increase to 90,000. So over here, this population here, P, they say that when this becomes 90,000, what is the value of n? So very simply, I let P goes to 90,000. In this case here, 12,000 e power 0.07n, I let this equal to 90,000. Okay, then I solve for n. So over here, very simply, I can first simplify the numbers first. E power 0.07n. I divide both sides by 12,000. On the right side, I'll get 7.5. Okay. Then over here is a very simple logarithmic equation solving. To find unknown powers first, I must take logarithm. Since I have a base e, I'll take ln. So therefore, ln e power 0.07n is equal to ln 7.5. Okay. Then from here, I can simplify further. So therefore, this means that 0.07n is equal to ln 7.5. And continue simplifying. N is equal to ln 7.5 divided by 0.07. Okay. So in this case, n should be about 28.8. Round off to 3SF. Okay. So that means that the question here says, find the year. So that means for the population to increase to 90,000, they need 28 years, and sometime in the 28 year, because there's a 0.8 here, that means it will hit 90,000 in the 28 year, not the 29 year, because even though if you round up, you round up to 29, but since it's 28.8, it means that it will hit 90,000 within the 28 year. So therefore, the year in which the population will have first increased to 90,000 would be the year, the year which population would first increase to 90,000. We count 28 years from 2005. So would be 2005 plus 28 years, which is equal to 2033. Okay, and that is your final answer to this question. Okay, and this is for question B4. Alright, so great. Let's now move on to question B5. Okay, let's look at part A first. Given this log equation here, log base 3 x minus 19 equals to 4. Evaluate log x. LG means log base 10. Okay, So over here, how do I find this? Very simply, I simplify my log. I turn this to exponential form here first. Okay, x minus 19 is equal to 3 power 4. This means that x minus 19 is equal to 81. X is equal to 100. So therefore, log x will be simply equals to log 100. And this answer is simply 2. Okay, and this is for part A. Let's now look at part B. Solve the equation. Log base 10 x plus 2 plus 7 log base 2 equals to, I need more space for this. Maybe I write this below. Okay, wait up. Okay, so over here, I write this part here. Okay, 7 plus log base 2 equals to log base 3, 9 plus log base 10, 2x plus 1. Okay, so over here, very simply, in order to simplify this first, I can make sure that I can combine them. Okay, take note, over here on the left side, I cannot combine this by product law first because the coefficient here is not 1. This is 7. So what I need to do is to bring up the 7 first into the power of 2. Then I can combine these two together. So let's do it step by step. Log base 10 x plus 2 plus log base 10 2 power 7 equals to, over here, log base 3. In order to get 9, I must have a power of 2. This is 2 plus log base 10 2x plus 1. Okay, now I can combine the left side together. Since coefficient is 1, by product law this will become 2 power 7 is simply 128. Okay, so this is simply log 128 times x plus 2. I put a square bracket so I know that this log applies to the entire expression here, equals to 2 plus log base 10 2x plus 1. Okay, then from here I want to continue simplifying from here. So over here, very simply, this is log base 128x plus 256. I can shift this LG, since it's a log base 10 as well, I can shift to the left side. So this will give me minus log base 10 2x plus 1 equals to 2. Okay, then now I simplify together. This is log base, log by quotient law, since the coefficient is 1, 128x plus 256 divided by 2x plus 1, this whole thing is equal to 2. Okay, so very easily now, this is my logarithmic form. I can now easily convert to exponential form. Okay, this means that in order to get 128x plus 256 divided by 2x plus 1, LG means log base 10. The base 10 here must have power of 2. Okay, so very simply, 128x plus 256 over 2x plus 1 is equal to 100. I can now simply solve this fractional equation. Okay, 128x plus 256 equals to 200x plus 100. Okay, so over here, very simply, 72x is equal to 156. Okay, x is simply equals to 13 over 6. Okay, and this is your answer for question part B. Alright. Okay, so let's look at the last part here. Part C, okay? Part C, find the value of x for which this equation here. So maybe I write over here, part C. Okay, equation is e power 2x plus e power x plus e power x minus 6 equals to 0. So very simply over here, what I do is that I can use substitution to make my life easier. Let u be equals to e power x. Okay, so this means that u square plus u minus 6 equals to 0. Okay, therefore quadratic equation you can simply solve by factorization. Okay, this will be equals to u minus 2 times u plus 3 equals to 0. So u is equal to 2 or u equals to negative 3. Okay, so very simply, when u equals to 2, this means that e power x is equal to 2 or e power x is equal to negative 3. And I see any exponential function e power x equals to negative number, I reject straight away. Rejected, as e power x is strictly positive. Okay, so over here, if e power x is equal to 2, this means that x is equal to ln 2 if I take ln on both sides. Okay, therefore round off to 3SF, it is simply 0.693. Round off to 3SF. Okay, And this is your answer to part C. Okay, and this is for question 5. Alright, so now let's move on to question 6. Okay, question 6 over here. Find the value of y when x equals to 4. Very simple. Okay, part 1, y equals to log x. Part A, when x equals to 4, very simply, just sub in only, y is equal to log 4. Okay, round off to 3SF is 0.602. Okay, and for part B, when y is equal to 1.5, in this case here, 1.5 is equal to log x. To get x, the base 10 must have a power of 1.5. Okay, press in your calculator, you should get 31.6, round off to 3SF. Okay, and this is for part I. Alright. Let's look at part 2 now. Part 2 here, sketch the graph of y equals to log x. This one is very simple. You should know how to sketch this graph here. Very standard graph, very standard shape. So over here, the log graph, y, x, simply it will be a sketch of this graph here. This is your log graph. Doesn't touch your y-axis. Okay, cuts your x-axis here. Intercept here is 1. Okay, this is your graph of y equals to log x. Okay. Okay, and the last part here. Okay, part 3. In order to solve this equation, a graph of a suitable straight line is drawn on the same set of axes. Means that, so to solve this equation here, I'll draw a graph of a straight line on this axis here. So how do I do that? Let's start by the equation given first. Okay, I must have the equation here. Let's write out x equals to root 10. Oh, sorry. X root 10, x times root 10 equals to 4 root 4 10 power x. Okay, so to make life easier, let's maybe what I can do is that I can take log on both sides first. Okay, why do I want to do that? Okay, let's explore what can we do with log. Okay, if I take log on both sides, this is x times root 10 equals to log 4th root of 10 power x. Because of this log here, I can now split apart this term. I can also bring down this root 4. Root 4, the fractional power is 1 over 4. Okay, so over here, what this means is that I can split apart by my laws of logarithm. This is log x plus log square root 10 equals to, maybe I'll do it step by step so that you can see clearly. This is 10 power x, the whole thing power 1 over 4. Because it's the 4th root. Okay, so by product law, by power law, I can bring the power down. Same thing for square root. Here, square root means power half. Okay, so by power law, I can bring the power down. This is not plus, sorry. Log x plus half log 10 equals to 1 over 4 log 10 power x. Okay? Then I can actually even bring this x power here, forward, down. So this is simply even log x plus half times log 10, log base 10. In order to get 10, the power is 1. So this is simply 1. So this is plus half equals to, I can bring down the power here, x. This will be 1 over 4 times x, which is x over 4. I'm left with log base 10 here, which is simply 1. So I'm left with like that. Okay? So this means that if I were to rewrite this equation, I'll get log x equals to x over 4 minus half. Okay, and therefore, since the graph I'm drawing is y equals to log x, since y is log x, this means that the graph I need to draw is the graph of y equals to x over 4 can be written as 1 over 4 x minus half. And this is the equation of straight line I need to draw, whereby in this case over here, 1 over 4 is the gradient, negative half is the y-intercept. I hope you can see this is the form of y equals to mx plus c. Okay, so therefore in this case over here, in order to solve this equation here, I can simplify this equation to get this form over here, to a straight line graph whereby y is equal to this mx plus c. So therefore, to answer the question, okay, therefore the equation of the line in this case is simply y equals to 1 over 4 x minus half. Okay, that is the answer for part 3 of this question. Okay, and with that, we're done with question 6. We will move on to the last question on here, question 7. Okay, let's now look at the last question here. Okay, given that in this case here, log base 2x equals to p and log base 4y equals to q, express the following. Let's start with part 1. Log base 2xy. This is very simple. Okay, this one can be split apart by my product law. This is simply log base 2x plus log base 2y. Okay, continue simplifying here. Question gives me that this is already p, but here the question gave me base 4. I have a base 2 over here, so I must turn this to base 4. So by change of base formula, log base 2x plus log base 4y over log base 4(2). Okay, continue simplifying. Okay, log base 4y, I know that this is already q, but log base 4, in order to get 2, I must have a square root 4. So that means in order to get 2 here, I must have 4 power half. So in this case, it will be a half. Okay, so I continue simplifying. Anything divided by half, it is the same as multiplying 2. I hope you can see that. Okay, this whole thing here is the same as the numerator times 2. Why? In case you are not sure, this is simply times. If I multiply 2 to the numerator and denominator, this denominator will become 1, whereas the numerator here will have a times 2. So this is simply equals to log base 2x plus 2 log base 4y. Okay, therefore this is simply p plus 2q, and this is for part 1. Okay. Okay, let's now look at part 2 over here. Part 2, log base 4 x divided by y. Okay, very simply by my quotient rule, this means that log base is equal to log base 4x minus log base 4y. Okay, then over here, I don't have a x in terms of base 4. I need to change this base to base 2. This is simply log base 2x divided by log base 4 minus log base 4y. Okay, so continue simplifying, I'll get log base 2x over log base 4 is to get 4 base 2 must have power of 2 minus away log base 4y. Final answer is simply p over 2 minus q. Okay, and this is for part 2. Alright. Okay, let's now look at part 3 now. Okay, part 3 here. Part 3, I have log base x to get 4y. Okay, in order to do this, okay, I note that over here the question never give me any unknown base. I must make this a certain number that I know. So let's choose the exam number. Let's say I choose base 2. By change of base formula, this is log base 2 4y over log base 2x. Okay, then the top part I can split apart by my product law. This is log base 2 4 plus log base 2y. The whole thing divided by log base 2x. Okay, and I continue to simplify from here. Log base 4 is 2 plus, in this case over here, log base 2y. Log base 2y, did I solve it earlier? Log base 2y. Okay, you can see actually from the part 1 here, I found that log base 2y is actually 2q. Okay, so over here I can just simply write over here, 2q divided by log base 2x is p. Okay, and that is my final answer for part 3. Okay, then the last part, part 4. Okay, I want to have, what's the question? Part 4 here, x square y. X square y. I want to find what is x square y. Okay, equals to, so over here, I don't know how do I even get this right. So let's start by what the question gives us first. Okay, this one here, I need to find. I start by what the question gives us. Log base 2x is equal to p. Convert this to exponential form. This means that x is equal to 2 power p. Likewise, I have log base 4y equals to q. This means that convert this to exponential form, y is equal to 4 power q. Okay, so therefore this means that, therefore x square y is simply 2p the whole thing square times 4 the whole power q. Therefore, simplify this. This is simply 2 times 2p. Remember, by your laws of initials, this is p times 2, not p squared. Okay, some of you may tend to make careless mistakes over here. Okay, then over here, times 4. Let's make them the same base so I can combine together. This is 2 squared, the whole thing power q, which will give me 2 power 2p times 2. This is 2 times q, which is 2q. Okay, so therefore, combine everything together. My final answer should be base 2, power add together, 2p plus 2q. Alright, so therefore, this is the answer to the last part and the end of this revision set questions. Okay, so I hope that you're able to answer these questions after watching this video. And this will be the end of this video.